Aloha and welcome back to our notes on matter. And we're going to be picking up with the molecule today. We've just talked about the atom and the various different particles that make up the atom. But we're going to be talking about molecules and things called ions today in this segment. So we've established that the smallest particle of matter is the atom. And atoms by themselves are atoms of certain elements. Elements like hydrogen and lithium and gold and oxygen, etc. But but atoms will want to join together for certain reasons. We say they bond. Oops, I didn't mean to do that. We say they bond together. And when they do, when two or more atoms join, we say they bond to form a molecule. Now, the little graphic right here is kind of silly. It's two atoms bonding, like a father and the son having a catch bonding. But I guess you could think in the same way that humans kind of get closer together when they bond and have quality time together. Atoms join together as well. So atoms are naturally electrically neutral. Remember, we said all the positives plus in lithium are balanced out by minus, minus, minus. And so all those forces are balanced out. And so the forces are neutral. So why would they bond? Why would they join together? I mean, after all, if humans bond or kind of join with others and get closer to others, it's to fulfill some sort of a need, right? What need do atoms have when they bond? Well, atoms are electrically neutral, but more important than that, and I need to be careful about using this word, they want to. Atoms aren't living things, they don't have wants. But I should say they're most stable when they have their outer electron orbits filled. Remember how we talked about how lithium had a certain, so let's just say this is lithium right here. 1, 2, 3 protons and 1, 2, 3, 4 neutrons right there, and it had a certain number of electrons, an electron there, an electron there, zooming around the nucleus. But the third electron was out in its own shell. It's out in its own orbit out here. Do you remember that? Okay. Well, atoms are most stable when they have their outer shells filled. And this shell right here, or this orbit that this one single electron is in, could hold a lot more, and so it's not filled currently. All right? Each shell can hold a specific number of electrons, which I'll tell you in just a minute. And so what atoms do is they join together so that they can make their outer electron shells, or their outer electron orbits, filled. And in some cases, this orbit right here with lithium, you can either add a lot more electrons and fill that up, or in some cases it might be easier to lose an electron, and so that this is the only energy shell, and that is filled. So it might make more sense if I actually gave you the numbers, so we could see how many electrons each shell can hold. Okay, so the first shell, you can see this one right here, can only hold 2. All right. And when I say shell, I mean it's an orbit, but it's like a three-dimensional shape, so it's like a sphere, sort of. All right. So imagine these two electrons in the same sphere, the same distance away from the nucleus. All right. The second shell can hold 8. So we've got 1, 2, 3, 4, 5, 6, 7, 8. The third can hold 8 as well. 1, 2, 3, 4, 5, 6, 7, and 8. The fourth shell can hold 16, and the fifth can hold 16 as well. So that's why you see more and more going out from the nucleus. Of course, the further out you go, the larger the circle, or the larger the shell, and so it should be able to hold more electrons. All right, but this matters because depending on how many electrons are naturally occurring in there, it might make the outermost shell full, or in most cases not full. So that an atom is going to want to join with other atoms to to satisfy the outermost shell. And again, it may make more sense if we actually do sort of just a little thought experiment right here. Okay, so we have two atoms. One is lithium that we should be familiar with. Lithium in its nucleus has 1, 2, 3 protons. It's not really centered very well, is it? I'm going to erase that. Try that again. 1, 2, 3 protons, and it has 1, 2, 3, 4 neutrons in there. Okay? We know that from before. And if you flip back to your periodic table, you'll be reminded that lithium has 3 protons because that's the atomic number. But it also has 1, 2, write it down here, and 3 electrons, or naturally occurring lithium. So these two guys right here are filling that first shell, and if you look back and see that the first shell can hold 2, the first shell is filled, and so this third guy got bumped up to the next shell. But he's in the shell all by himself. And that atom is not all that stable because you've got the single electron all by itself in this shell out here. This atom is not entirely happy. Happy in being in quotes, of course. Well, we also have this atom right here of fluorine. If we look at our periodic table, if you flip over, fluorine is in the upper right. It's a big capital F. Actually, you know what? This should be just an F right here, not FL. Its cousin chlorine is Cl, but fluorine is just F. So that's my mistake right there. That should just be F right there. So look for F, and you'll see that fluorine has 9 protons. Let's go ahead and write them in. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and it has, let's see, what's the number at the bottom there of fluorine if you look at your periodic table? That's 18.998, which is very close to 19. So that must mean that there must be 19 particles total. If 9 of them are protons, then there must be 10 neutrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 neutrons in that nucleus right there. Okay, for a total of 19, which is very, very close to that average number of 18.9998. Okay? Well, why does this matter? Well, because we have 9 protons, it means we must have 9 electrons as well. Where do they go? They go outside in the energy shells. So the first shell can hold 2. So there's 1, 2. Where do the rest of them go? They go in the next shell out. All right? 3, 4, 5, 6, 7, 8, 9. Okay, so there are 2 here, and there are 1, 2, 3, 4, 5, 6, 7 in the next shell. Again, if you flip back to the previous page in your notes where it says how many electrons can the second shell hold, it would say 8. So this atom right here of fluorine is not satisfied either. It wants to gain an electron so that its outer shell is completely full. Coincidentally enough, lithium right here would love to get rid of this electron because then this would be the outer shell and it would be full of 2 electrons. So these atoms are going to join. They're going to bond together. And so this, I'll write this in red, I guess. This electron, first of all, these 2 atoms are going to join together. And this electron is going to kind of jump over and mostly spend its time with fluorine and no longer be on the lithium side. All right? Now, in order for this to happen, these 2 atoms need to be close together. And so this outer shell right here is completely full with 7 plus the borrowed electron. And now there is no longer this outer shell for lithium, but this is the outer shell, and it's full of 2, which is what it can hold, and so lithium is stable as well. And so these 2 atoms travel around together. They have formed a bond. They've joined together because lithium wanted to give up something, fluorine wanted to gain something, and so now they're both, again, they're not really people, they don't have feelings, but we can say they're both satisfied, they're both stable right now, and so they travel around together as a molecule. Okay? So, when atoms bond, we say they form molecules. They can be two or more of the same, like for example, oxygen. All right, oxygen. There's an oxygen right there, another oxygen right there. Well, that's a little bit bigger than the other one, but you get the idea. They travel around together. All right, that's what you breathe right now. They travel around in pairs because oxygen by itself, right here, is not stable. This one right here, H2O, you're probably familiar with that. All right, that is one atom of oxygen and two atoms of hydrogen joined together. And they actually sort of make sort of a, we call it like a Mickey Mouse head shape right there. Even that hydrogen isn't quite the same size as the other one, but they join together. So oxygens kind of travel around like that. H2O, or two hydrogens and one oxygen, travel around in sort of this oddball shape right there. But these are both molecules, so they can be the same atoms or they can be different ones. Both give us molecules. Which leads us to kind of the last idea in this video segment, and that is the concept of an ion. All right? What an ion is an atom that gains or loses electrons. All right, now wait a minute right here. Which atom, if you flip back, which atom with lithium and fluorine gained electrons? Well, fluorine did, right? Fluorine, just F, not FL, gained one electron from lithium. And then lithium lost or gave up one electron to fluorine because that made both of them stable, made both of them happy. So both of these are what we call ions. Why is that? Why does that matter? Because this gained one electron. Actually, I should erase that right there. It gained one, which means if it gains one electron, well, that means it's got an extra electron, and since electrons are minus, we say that it's got an extra -1 charge now, right? If you lose two electrons, okay, it's subtracting two electrons, which are minus. Okay, well, if you take away two minuses, what do you get? You get +2. Right, if you gain three electrons, which are negative or minus, well, that would be a -3 charge because you've got three extra minuses than you would normally had. If you lose one electron, very much like very much like lithium, you're going to be +1. Why? Because you lose one electron. Oops, and so since electrons are minus, if you lose a minus, then that means you are +1. So, atoms that join together, that give up an electron, as lithium does, or gain electrons like fluorine do, are called ions because they're not a neutral charge anymore. They've got an unbalance of charges. That's okay, because in order to do that, or they do that in order to become more stable. But it does mean they have a certain charge, and therefore they've got certain forces and certain properties that cause them to interact with other matter. So that's going to be it for ions and molecules. We're going to pick up with pure substances versus mixtures in the next segment. But for now, thanks for following along. Please make sure you ask me if you have any questions, and I'll look for you on the next segment.